It is time for lesson 1.8, solving rate problems. This is the last lesson in our unit 1, and then we'll be talking about our tests that is coming up. We did skip lesson 1.6, which is dealing with conversions. We're going to get into conversions later on, not only in math, but also in science, and look a little deeper than what the book has to offer. So please, at this point, as we get ready for our test, make sure that all of your previous lessons have been completed and turned in. And if you want to make corrections, you do so that you have good reference tools for your upcoming test. All right, as we get into the swing of things, please make sure that you're taking notes. Once again, you can listen and hear and see, and you can say, hey, I watched the video, but you didn't take any notes. You didn't learn the math. People can't learn math without doing math. So taking the notes is vital. And once again, in all of my lessons, I'm going to be covering extra things that you should have already learned and know by heart. But if you don't, those are good things to take notes on because I'm explaining maybe some of those gaps that you have from previous years, and we can fix those problems or mistakes that you have rather easily. So please take your notes. You have your margins, you have a notebook paper, you can have post-it notes, whatever you need so you can get your notes written down, and then you have good examples when it's time for you to go do your homework. So when we look at what we are being asked to do, what our I can statement is telling us for our objective, we want to focus in on the idea that we're going to be using real world problems with rates and unit rates, right? And it's plural because we're going to have multiple unit rates and rates in each of these problems. So as we're going through it, I know on this page they have all sorts of writings, paragraphs, images, drawings for this question, but I think that just becomes more confusing to where if I look at it and I break it down piece by piece, then it becomes more clear as to what I'm doing. Once again, since unit 1 or lesson 1, we've talked about finding our original ratio. Well, in this case, I need to find my original ratios. So my original ratio is 20 miles in 4 hours. My second original ratio is 248 miles in 4 hours. By using those, then, we need to find our unit rate. So the overall problem says this. Destiny drove 220 miles in 4 hours. Santiago drove 248 miles in 4 hours. At these rates, how many more miles can Santiago drive in 9 hours than Destiny? You can create a bar diagram, but once again, I find that more confusing than just looking at what I'm being asked to do and setting up the math problem. So we're going to start by taking our original rate and we're going to find our unit rate. That, once again, is going to require division because I need to find out how fast this person was going in 1 hour. So I take what I have, and once again, I have 220 miles, and what I have always goes inside my division box. And then I look for the groupings I'm going to put it into. I put it into 4 groups. So 4 will be divided into 220. Now, yes, you can write this math problem down, type it into calculator, get an answer, write it down, and move on, but then you don't get your credit for showing your work. I need to see that you know how to divide because, once again, at the end of the year, you're going to have a pretty big test where you can't use your calculator and you have to be able to do these without a calculator. So we ask ourselves, will 4 go into 2? No. Will 4 go into 22? Yes. How many times? 4 goes into 22 5 times. If you didn't know that, then that's what the calculator's for. 22 divided by 4 gives you 5 and stuff. So we ignore the stuff, we keep the 5. 5 times 4 is 20, which gives me a subtraction problem of 22 minus 20, so 2 is left over. Bring down my 0, and 4 goes into 20 5 times. So we know that Destiny was driving 55 miles per hour. Now we take our second rate, the original rate for Santiago. I have 248 miles. Have goes inside the box. I'm putting it into groups of hours, so I'm going to divide it by 4. 4 will not go into 2, but it will go into 24. 24 divided by 4 is 6, and 6 times 4 is 24. I don't have anything left over, so I bring down my 8, and 4 will go into 8 2 times. That gives me a zero balance. So I know that Santiago was driving at a rate of 62 miles per hour. All right, so now with that said, we have to go to the second half of the question. I know the unit rate from my original rates for each of the individuals in the math problem. But now it says, well, how many more miles can Santiago drive in 9 hours? So I have to figure out how far at this consistent rate they would be driving in 9 hours. So I'm going to take my 62, I'm going to multiply it by 9. 9 times 2 is 18. I put down my 8 and carry my addition of 1. And then 9 times 6 is 54 plus 1. Well, that's 55. Then I have to do the exact same thing with Destiny's rate, and that's 55 miles per hour. So I have to multiply it by 9 to see how far she will go in 9 hours. 9 times 5 is 45. Carry my addition of 4, and then 9 times 5 is 45 plus 4, and that's 49. Now that I know how far both of them will be going in 9 hours at their constant rates, now I have to look at what is being asked. How many more? So how many more is telling me I need to subtract these two numbers. When I'm subtracting, it is important to put the biggest number on top. If I'm doing integers, I don't have to, but we'll get to integers much later in the school year. So just right now, keep in mind that the largest number has to go on top in order to do your subtraction. Once I have that set up, then I ask, will 5 come from 8? It will. 8 minus 5 is 3. Can I take 9 from 5? No. So therefore, I have to borrow. So I go to the front 5 in the hundreds position. I borrow from it. It becomes a 4. And then I carry my grouping of 1 over to the tens column. So instead of 5, I have 15. Now I have 15 minus 9, and that is 6. And then 4 minus 4 is 0. So what I'm left with is 63. 63 what? Well, what we're saying is that Santiago will be able to drive 63 more miles. That's your answer. So instead of doing all the boxes and the groupings for each of your rates, then if we just do these type of math steps, I really think it's going to be much easier. Is that a lot of work? It is. But guys, you're in middle school now. You're sixth graders. There's going to be a lot more work. And as the year goes along, there's going to be a lot more work. And as your years go along, in order to graduate high school, you have to take some math classes. And there's going to be a lot more work. But this is the basic work that we need to be able to understand to move forward to be successful, not just this year, but in your upcoming years. So before we actually start on example 1, I want to point something out to you that I thought that you had understood after having this program last year. But as I was working earlier this week with a couple of people and pointing that out, they didn't know that that was there. Maybe you did, maybe you didn't, but just as a reminder then. Example 1, right? So this is where we're going to work through a problem. Hopefully you'll have some post-it notes or some extra note papers where you are showing how you actually set up the problems. But that's there for a reason. So when you go to do things like your homework, so notice in your previous lesson, lesson 1.7, when I look at question 2 and question 4, they tell me which example from the lesson that was worked that I can go back to and see how it was set up. That means you could also go back into the video or the slideshows and see an example of it being worked through. So knowing and noticing what example you're using from the lesson on the homework could truly be beneficial to you. All right, so in this example, it says a warehouse sells 15-ounce cans of tomato sauce by the case. Each case contains 6 cans and sells for a price of $9.96. At a local grocery store, 3 15-ounce cans of the same brand of tomato sauce are on sale for $5.67. A caterer needs to buy 36 cans. Okay, so we have our original ratios. We can do the math and set it up. And we've got a few extra numbers in there. We got to figure out what to do with those. But what are we being asked? Well, in this example, then they've put it in bold what you're being asked. How much will the caterer save by buying 36 cans from the warehouse instead of from the grocery store? So we know that we've got a few steps that we have to do here. Our first step is always identifying what our original ratio is. So in my original ratio, I see that I have 6 cans and that they sell for a price of $9.96. Then my second one is that I have 3 of them and they sell for $5.67. Notice we underlined the 3, not the 15 ounce. We'll come back to that in just a moment. So how much will the caterer save? So notice we have 15 ounces. So what are we going to do with the 15 ounces? Absolutely nothing. They are there to confuse you. And notice they really try to confuse you by putting the 15 ounces before the price of 567 on your second ratio and the word 3 instead of the number 3, because they want to make sure you're reading it and understanding it and realizing that sometimes they throw things in there just to make sure that you know what you're doing. Don't let them trick you. We got this. So I'm going to start once again with my first one, and I'm going to figure out its unit rate. And a unit rate means how much per each one. In this case, then I know that what I have is $9.96. Previously, it was set up where the money came first. This time, we know that it's coming second. It doesn't matter as long as I'm asking, well, how much do I have to spend on it? $9.96. And then I'm asking, well, in my groupings, how many are in the group? Well, there are 6 of them. So to find my unit rate, I have to divide it by 6 to find out how much one costs. So what I have goes inside, and my groupings goes on the outside to divide. The buy-in of 36 cans we'll get to in just a moment, so please don't worry about that particular number yet. So $9.96 goes inside. I'm dividing by 6. I have a decimal inside my division, so my very first step has to be to raise my decimal. And I leave it in the same spot. And then when I'm dividing, I have to divide digit by digit. Will 6 go into 9? Yes. How many times? Well, if you don't know, you grab your handy dandy calculator. You do, once again, what's inside the division box, 9, divided by what's on the outside, 6 equals, and you're going to get 1 point stuff. So all we really need to know is the 1. 1 times 6, therefore, is 6. When I subtract, I get 3. I bring down my next number, which is a 9. Will 6 go into 39? It sure will. How many times? Well, you can take 39 divided by 6, and you're going to get 6 point stuff. We're going to ignore the stuff and use the 6. 6 times 6 is 36. I have 3 left over. Bring down my 6. Oh, and as we just said, 6 goes into 36 6 times, because 6 times 6 is 36. So if I buy them in groups of 6 cans and they're $9.96 a piece, or for the grouping, then I know that I spent $1.66 per can. But now I'm going to go to the grocery store and see what they're costing. So I have $5.67, and I'm putting it in groups of 3. So I have to put what I have inside the division box, and then I'm going to divide it by, my divisor is going to be my groups. Before I divide a decimal, I have to raise my decimal up and keep it there, and then ask my division questions by each and every digit. Will 3 go into 5? Yes, 1 time. All right, if you have to divide it on your calculator, you're going to see 1 point stuff. Ignore the stuff, focus on the 1. 1 times 3 is 3, so when I do that subtraction, I get 2. I go ahead and bring down my next number, which is a 6. 3 goes into 26 8 times. It would be 8 and stuff if you did it on your calculator, because 8 times 3 is actually 24. So I do have extra numbers. That's what the stuff is representing, is my remainder. So my remainder when I subtract 26 and 24 is 2. I bring down my 7, and 3 goes into 27, 9 even times. So I can see that at the grocery store, if I buy them for $5.67 for a group of 3, then I'm spending $1.89 per can. All right, so now I need to see how much money I would save if I bought 36 cans. So I could do this with all of these different steps like we did in the previous question, right? But if I do things with less steps, if I use smaller numbers, then I'm much more likely to not make any mistakes, right? So I'm going to show you a shortcut to these type of problems, if you will. And really, it's not necessarily a shortcut, but it will allow you to work with smaller numbers. So previously, if we had done it like the previous question, I would take the 166 and I would multiply it by 36. I would take the 189 and I would multiply it by the 36. And then I would subtract them. So here we're going to use a smaller number, and what we need to find first is the difference between the costs per unit. So if I take my $1.89 and I subtract $1.66 from it, then I can see what the difference is per can between buying them at the two different locations. Now, as I mentioned in a previous lesson, when it comes to decimals, if I have division, addition, or subtraction, I have to put my decimal where it belongs first in the answer. Multiplication? No, because I don't do it until last. So I have a subtraction with a decimal. I have to bring my decimal down and put it where it belongs. So when they're lined up, it goes straight down. That way I know that I'm not going to have an improper area. Now I ask, can I take 6 from 9? Yeah, I can. So 9 minus 6 is 3. Can I take 6 from 8? Sure can. That's 2. And 1 minus 1 is 0. So what we're finding is a difference of 23 cents. Now that I know that the difference is 23 cents, smaller number to work with, then we're going to multiply it by 36 and we'll see how much money will be saved. Multiplying multiple digits, then I have to start with the first number. So I start with the 6. 6 times 3 is 18. Carry my addition of 1. If you didn't know it was 18, get your handy dandy calculator, follow along with me and see where these numbers come from. Then I do 6 times 2, which is 12, plus the 1, so I have 13. Now this is the way that I show multi-step math problems that are multiplication, and I would strongly advise you to learn how to do it because some of you don't know how many zeros to bring down and when to bring down a zero. And on every lesson where I'm multiplying 2, 3, 4 digits, I do these exact same steps, and I say them every time we walk through it. So I'm going to go to my second number. Notice I underline it. When I go to my second number, what I say is, that tells me 2, so I circle however many positions are behind it. That's one position, right? The second number tells me to bring down, and however many I circled, because the circle looks like a 0, that's the number of zeros I bring down. I have to hold that place value when I'm multiplying, or my answer will be completely wrong. Once I've done that, then I just multiply with the 3. So 3 times 3 is 9, and 3 times 2 is 6. They're lined up correctly, nice and neat. I'm going to add those. Starting to the far right, 8 and 0 is 8. 9 and 3 is 12, carry my 1. And then 6 plus 1 is 8. Now, as we said, we don't line up our decimals in multiplication with decimals. So instead, to know where my decimal goes, then we're going to count decimal spaces. Notice I always emphasize it's spaces, it's not decimal points. There is one decimal point in the math problem, but we need to count the spaces, which is 2. So if there are 2 decimal spaces in the math problem, I'm going to move it 2 times from right to left. So what that tells me is the amount of money that's going to be saved is $8.28. Okay? So that just is one extra step in math. Now, just so you aren't confused, this is not a new type of math problem because when I look at what we could have done, so I worked it out going the original way, which was, once again, if I take the 166 over at the right per can, and I go all the way over to the left and I multiply that by 36 cans. It's more steps in multiplication and larger numbers. I can do the same thing with the over to the right, $1.89 over on the left, multiplying it by 36 cans. So then I have 2 larger dollar amounts that I have to subtract. Notice we still get the exact same answer, right? So you don't have to do the math with the bigger, but if you want to do it that way, I'm never going to count it wrong because there's more than one way to do math. As long as your steps are logical, you show me your work, you get the right answer, then I'm happy to let you do it that way. All right, so try this process on this particular question. What I'd like you to do is pause the video and set it up. If you're just really not sure, then watch me as I work through it on the video and pause when I get to the setup, and then you do the work. I want you to see how far you can get without having to go back and look at my steps. Then I want you to listen to me explain it and work through it. So pause the video now and then come back to me. All right, so the problem says Miranda typed 325 words in 5 minutes, while Joseph typed 295 words in 5 minutes. At these rates, how many words more can Miranda type in 9 minutes than Joseph? So we have a couple steps we have to do here. First, I identify my original ratios. I have 325 words in 5 minutes, 295 words in 5 minutes. I have to change them into unit rates so that I can then use that information and apply it to 9 minutes. All right, so now I got to start with what I have. So when it comes to Miranda, I have 325 words. I'm putting it in equal groups of 5, so I have to divide by 5 to find my unit rate. Will 5 go into 3? No. Will 5 go into 32? Yes. It goes in 6 times with stuff left over. I ignore the stuff. 6 times 5 is 30. Have 2 left over. Bring down my 5. 5 times 5 goes into 25 5 times because 5 times 5 is 25. So you should have found that Miranda can type 65 words per minute. Did you get that far? Right? And if you didn't and you made a mistake, look at your math, look at my math, and see where your mistake might be. Your second one that you should have worked is with Joseph's rate. He did 295 words. That's what we have. And he did it also in 5 minutes. So that's the groups we put it in. So we asked, will 5 go into 2? No. Will 5 go into 29? Yes. How many times? Well, 5 and stuff. So we get rid of the decimal point and the stuff behind it. We keep the 5. 5 times 5 is 25 with 4 left over. I bring down my 5. 5 goes into 45 because it does end with a 5 or a 0. So it goes in evenly. We have 9 times because 9 times 5 is 45. So we know that Joseph can type at 59 words per minute. So now we need to find what their difference is, right? I need to find out what the range difference is in order to do the calculations for 9 minutes overall. So if we have 65 words with Miranda and we have 59 words with Joseph, the difference between them in a minute's time is 6 words. So how many more will Miranda then be able to type? So if I have in 9 minutes, how many more? Then we're going to multiply. So 9 times 6 tells me 54. Miranda will type 54 more words than Joseph in a 9-minute period. Did you get there? Do you understand it? Maybe you need to stop and rewatch it just so you do make sure that you have it. If not, we move on. So then we have all of these words. So this is what I was talking about earlier, where they're going to show you, you can use ratio tables, you can do double line graphs, you can do all this stuff, but that's just a lot of work and a lot more steps that you have to do. I don't expect you to do all that, right? And the more steps you have, once again, the more likely it is for you to make mistakes. As we have worked through these first 7 lessons, I've tried to make connections to things that we have taught before. In the same way, I've also said on every one of the lessons, math is truly about finding a systematic way of doing it and thinking about what we're being asked to do. This is one of those situations where we can make our lives a lot easier by thinking about what's being asked and then applying some of the skills we've already learned. So let's read through this. It says a veterinarian measured the number of heartbeats of her dog and cat for 4 minutes and recorded the results in the table. At these rates, how many more times does the cat's heart beat in 6 minutes than the dog? So then it says use equivalent rates. So the process that we're going to do is going to be different than what the book shows. So once again, please make notes so you can go back to this example and you can see the best way to do this. Now, there's nothing wrong with doing it the way the book says, because once again, there's more than one way to do a math problem. I'm going to try to show you the easiest way to do it, as well as why we're going to approach it that way, because we got to think through the problem. First and foremost, though, is always define my original ratios or my original rates. And when I look at the dog, I have 360 beats for how much time? Well, that's 4 minutes. When I look at my cat, I have 520 beats also for 4 minutes. So when I'm looking at how I'm going to set it up, beats per minute, if I stop and think for just a moment, well, they have the exact same denominator. They have the exact same amount of time that it was recorded. So what we could do is find the unit rate for 360 divided by 4. We could find the unit rate for 520 divided by 4, and then find the difference between those unit rates. Or we can say, well, if they're both out of 4 minutes, then all I need to do is look at the numerators, the 360 and the 520, and start by finding their difference. We're going to eliminate a couple steps and hopefully make our life a lot easier by thinking about an easier way to approach the problem. Subtracting, I have to start with my larger number on top. So 520 over 360. Then I start over to the right. Can I subtract zeros? Yes, it's 0. Can I take 6 from 2? No. Now, what often happens, let me explain this, with 6th graders is they're like, well, I can't take 6 from 2, so I'm going to flip it in my head, and I'm going to write down that it's 4. And what I often do with my 6th graders, and it might seem silly, but I say, well, on that top number, put that number of fingers up. So if you put 2 fingers up and then ask, can I take 6 from it? Then you're like, no. That's a real quick and easy check, just to make sure that you know your proper steps of subtracting. It's an easy thing that I used to teach my 3rd graders. And then when I started teaching in 6th grade, some students just miss that in the early ages. So once again, when I'm looking at my numbers and I'm going to subtract, if you need to, put the number or the digit of your fingers up for that top number and ask if you can take that bottom number out. 2 fingers up, can it take 6 from it? No. So then I know I have to borrow. 5 becomes 4, and then the 2 becomes 12, and now I can subtract. Good luck trying to put 12 fingers up. 12 minus 6 is 6, and then 4 minus 3 is 1. So what we have now is a difference of 160 beats per 4 minutes. Do I have to find my unit rate? No, because if I look at what we're being told, now I'm saying, well, it's out of 6 minutes, so if I put it equal to 6, that setup should look very familiar. Once again, I'm going to try to teach you the ways that will always work in systematic math that you can carry forward. Could you ask, well, what am I multiplying 4 by to get 6, and then divide 6 by 4 to find a decimal, and then multiply the numerator by that decimal and find the answer? Absolutely. Or you can divide the loop, right? So dividing the loop, for me, I think it makes it a lot easier for our students. If I take 160 and I multiply it by 6, I'm going to find out that that's 960. Then we divide by the lonely number. The lonely number is 4. So I'm going to take 960. I'm going to divide by 4. Will 4 go into 9? Sure will. How many times? If you need to put it on your calculator, you find out that it's 2 and stuff. So I know I'm going to keep the 2, and it's going to go above the 9, and that I'm going to get rid of that stuff. 2 times 4 is 8. Subtract, I get 1. I bring down my 6. 4 goes into 16, 4 even times, because 4 times 4 is 16. I have a 0 remainder. My answer is not 24, because once again, I have another 0. If it was a decimal, then I could talk about that, but this is still a whole number. I have to hold that place value. If I have a number to bring down, I have to put a number up. I'm going to put a 0. There's a big difference between 24 and 240. So what we found is that it's 240. So how many more beats was it? 240 more beats. We eliminated several different problems that we'd have to do to get to that same answer. Nothing wrong with doing it the long way. I'm trying to show you an easier systematic way that you can do it. Notice it says example 2, and when you go to do your assignment, you might see some problems that say, hey, you can use example 2. So please take notes. I know the book gives you all sorts of steps and words and things you have to read and boxes, and I'm going to show you once again the systematic way of doing math that you can build upon more than once. So there is more than one way to do the math problem. You do what works best for you. As I read it, it says a bulk food store sells a 12-pound bag of red delicious apples for $18. At this rate, what is the price of a 15-pound bag of apples? So we're looking at ratios, we're looking at rates, we talk about unit rates, and we have to go and find the originals once again. The first one is I have 12-pound bag and it cost me $18. The second one says I don't know how much it costs, but it's a 15-pound bag. So in my comparing equivalent ratios, I'm missing a piece. Well, I have pounds at the bottom and money at the top, but if I'm missing a piece, hopefully I stop and I think, hey, if there's a piece missing, then I know I can divide the loop to find that missing piece and not have to do all those extra steps. So that's what we're going to do. I'm going to start by saying that my original rate that's given, I have 12 pounds of apples and it cost me $18. I know that's equal to 15 pounds, but I don't know how much that cost. Now, once again, there's more than one way to do math. If you want to figure out what you're multiplying 12 by to get 15 and then do the same by 18, you can. You're more than welcome to. I find that to become more difficult, especially because many times you're going to end up with just long decimal numbers. So if we divide the loop, then I'm going to loop the two that are diagonal to one another. 18 times 15 then on your handy dandy calculator tells you that that's equal to 270. Once again then, when I find that product, I'm going to divide by the lonely number. That's step 2. So 270 divided by 12. Will 12 go into 2? No. Will 12 go into 27? Yes. So however many times it'll go into 27, it goes above the 7 because I asked about the second number inside my division box. Well, when I take my handy dandy calculator, I do 27 divided by 12, I see that I get 2 and stuff. So I ignore the stuff and I keep the 2. Because 2 times 12 is 24. When I subtract, I get 3. I bring down my 0. 12 will go into 30, not evenly, but it will go into 30, well, 2 again. And I still, once again, have stuff. Ignore the stuff. 2 times 12 is 24, and I'm left with a 6. Now, I have nothing else to bring down, but in 6th grade, we don't write remainder something, right? So we're going to either make fractions or decimals, and since we're dealing with money here, we're going to do decimals. So I'm going to add a decimal at the end of my number inside the box and then bring it up. That way it's in the right place. Then I can add my 0, bring it down, and do my next step of math. 60 divided by 12 is 5, because 5 times 12 is indeed 60. So I end up with 22.5, but we're dealing with money, right? And since I'm dealing with money, I have to remember that money has to have 2 decimal spaces. So I can't keep an answer of 22.5. It has to be $22.50. And that's your answer. All right, so one more problem and then the lesson is yours. The manager of a small bakery determines that an average of 264 loaves of cinnamon raisin bread are sold every 12 weeks. At this rate, about how many loaves of cinnamon raisin bread are sold every 5 weeks? So as we're looking at it, then once again, we have to find those original rates and ratios, right? So I want you to do this on your own. Check your answer when you're done. Couple of things. Make sure you have your original ratio and rate set up correctly. I would strongly suggest that you divide the loop and use your calculator as you go through your steps. Just make sure you show your work. So pause, find the answer, and let's see how you did. So hopefully you did pause and you found your answer and we see how you did. All right, so we know that we're talking about 2 different labels. We have weeks and we have number of loaves. And in the weeks for the original rate, we have 12 weeks. And in 12 weeks, we have 264 loaves that are sold. And now we need to find out what it's going to be equal to for the loaves if I only do it for 5 weeks. And once again, if we divide the loop, we can find that missing number. So we loop the 2 that are diagonal and we multiply them. You could use your handy dandy calculator if you'd like. You're more than welcome to. But I multiply 264 by 5. That'd be 1,320. Now we divide by the lonely number. So 1,320 divided by 12. Will 12 go into 1? No. Will 12 go into 13? Yes. So whatever answer I get goes above the 3 now. So 12 goes into 13 one time, because 1 times 12 is indeed 12. I have 1 left over. I bring down my 2, and I get 12 again. So 1 will go up at the top, because 1 times 12 is 12. I have a 0. Now, I can't stop at 11 because I have something to bring down. And if I have something to bring down that 12 won't go into, I have to bring something up still. So 12 goes into 0 how many times? 0 times. So hopefully you found that when it comes to the lobes, that you have 110 lobes. And if you want to be specific, it'd be in 5 weeks. Is that what you got? If not, please ask me for help and I can help you and we can figure out where you might have made a mistake. Now, you're not going to have any homework this evening because this was a long lesson, will take most of your time. So once you have all of your notes, you are done with math for today. Please find something else to work on calmly around the room or at your desk, and then we will do the assignment in the next class.